Hello everyone. Today let us discuss about dimensional formulae and dimensional equations. This is a part of second chapter in 11th standard. It is very important to know dimensional formulae because not only for 11th standard, these are very useful for the coming academic year, that is 12th standard also. We will get various quantities, various variables. For all of them, we have to write dimensional formulae. So, if you learn in the beginning properly, throughout this year and also in the coming year, it will be very easy for you to write the dimensional formula for any given quantity. Therefore, let us learn neatly about this dimensional formulae and dimensional equations. As we have seen, so many quantities are there in physics. The nature of a physical quantity is described by its dimensions. All the physical quantities represented by derived units can be expressed in terms of some combination of seven fundamental or base quantities. That means derived units, any physical quantity which can be represented by derived units. In our previous video, we have seen seven fundamental units that is the kg for mass, meter for length, and second for time, like that seven fundamental units we have seen. Now some quantities cannot be measured directly with a single unit. For example, if you have velocity, velocity is expressed as distance divided by time. Therefore, SI unit for velocity is meter per second. This is a derived unit. It is taken as a combination of meter and then second. So, we have seen in the earlier video seven fundamental quantities, that is many we have seen. In all those seven, three are important, that is kg, meter and second. The others are also in the previous video. If you want to go back to the previous video, you can go back and see the seven fundamental SI units. Now we are talking about the derived units. For velocity, we express it as meter per second, and acceleration, we express it as meter per second square. These are the derived units. So, velocity is a quantity which is represented by derived units. Acceleration is a quantity which is represented by derived units. Like that, we have so many other things in physics. If you go back to the backside appendix, we will find many quantities which have dimensional formulae. Now, let us see the base quantities are called, these base quantities are called as the seven dimensions of the physical world. The base seven quantities which we have seen earlier in the earlier video, these are called as the seven dimensions of the physical world, which are denoted with a square bracket. Now, for example, if you take length, length is represented by capital L in between square brackets. As I have shown here, these are the seven base quantities. So these seven base quantities, for length, it is represented by capital L between the square brackets. Mass, capital M, all are between square brackets only. Time, T, capital T. Electric current, ampere, A between square brackets. Thermodynamic temperature, capital K between square brackets. Luminous intensity, CD, that is candela, between the square brackets. Amount of substance, mole, MOL, between the square brackets. So this is L, that is for length, mass, time. This is for electric current. K stands for Kelvin, and then that is for temperature. CD, candela, stands for luminous intensity. Mole, that is for amount of substance. So these 7 base quantities are called as the 7 dimensions of the physical world. The dimensions of a physical quantity are the powers to which the base quantities are raised to represent that quantity. So I will explain it neatly. So dimensions means we are giving them powers. Powers means they are raised to the powers, like x square, x to the power of 4. Like that we write powers now in the same way. These L, M, T, A, K, C, D, M, M, O, L, they are raised to the powers. That is L to the power of 1, M to the power of 2, T to the power of minus 2. Like that, for example, I'm saying. So like that we raise them to the powers. Those are called as exponent. So we raise them to the powers, then that will become the dimensional formula. Now, if you see, if you go back to this one, the dimensions of a physical quantity are the powers to which the base quantities are raised to represent that quantity. Now, if you see, they are represented in the square brackets around the quantity. It means we are dealing with the dimensions of the quantity. We are dealing with the dimensions of the quantity. So, what we are doing here is we represent them within the square brackets like this. Therefore, it means we are dealing with the dimensions of the quantity. In mechanics, all the physical quantities can be written in terms of dimensions L, M, and T. Mainly, as I told you, these three are the main things through which we represent every physical quantity. In our mechanics, all the physical quantities can be written in terms of dimensions, that is L, M, and T. Now, for example, if you take volume, volume is equal to length into breadth into height. This length is measured in meters, breadth is also measured in meters, height is also measured in meters. Length is, it is nothing but length. Breadth is also one kind of length. Height is also one kind of length. Therefore, we can write in place of length capital L, in place of breadth capital L, in place of height capital L. Therefore, it is L into L into L, that is L to the power of 3. So we can write it as L within the brackets, outside 3, you can write as the power, or you can also write L3 within the brackets. Both ways are correct only. Now, if you see this volume, in volume we don't have time, we don't have mass. This volume is independent of mass and time. There is nothing related to mass and time. Therefore, mass has 0 dimensions for volume, and then time also has 0 dimensions for volume. Therefore, we can write it as L3, L to the power of 3, M to the power of 0, T to the power of 0. L to the power of 3, M to the power of 0, and T to the power of 0. So generally we write M first, therefore M0, L3, T0. This is the dimensional formula for volume. This is the dimensional formula for volume. In this way, we express all the physical quantities in terms of L, M, T, and also other 4 quantities which we have seen in the previous picture. Now, let us take another example. Force. Let us take force. We all know Newton's second law, F is equal to M into A. All of you know Newton's second law, F is equal to ma. F means force, m is mass, a is acceleration. Therefore, force is equal to mass into acceleration. Force is equal to mass into acceleration. But mass is equal to, that is mass into, but acceleration is equal to length by time square. Acceleration is equal to distance by time square. Distance comes under length. Distance comes under length. Therefore, acceleration can be written as length divided by time square. Length divided by time square. Therefore, therefore force is equal to mass into length divided by time square. Therefore, mass for mass, you can write m within the square brackets. Length, you can write L within the square brackets. Time square, that is divided by time square. That means when it comes to the numerator, time to the power of minus 2. Therefore, we are writing here t to the power of minus 2. So, keeping them together in a single square bracket, m1 L1 t minus 2. When there is a power 1, sometimes we don't specify it. So we can simply write it as m1 L1 t minus 2. m1 L1 t minus 2. This is the dimensional formula for force. This force has one dimension in mass, one dimension in length, and minus two dimensions in time. So, force has one dimension in mass, one dimension in length, and minus two dimensions in time. The dimensions in all other base quantities are zero. All other means just now we have seen, that is absolute temperature, that is capital K Kelvin, and then amount of substance mole, intensity of light candela, current, that is ampere. So those four are not here. Therefore, for all of them, the dimensions are zero in the case of force. In the case of force. Now, in this type of representation, the magnitudes are not considered. In this type of representation, the magnitudes are not considered. It is the quality of the type of the physical quantity. Sorry, it is the quality of the type of the physical quantity that enters. In this type of representation, the magnitudes are not considered. It is the quality of the type of the physical quantity that enters. I will explain it. For example, if you take change in velocity, in the coming days, in the third chapter, you will see acceleration is rate of change of velocity. Then we will take v minus u. Like that, we take that is change in velocity, or else initial velocity. It is given by a small letter u, average velocity v upon a small line v bar, final velocity given by the letter v, and speed, which is a scalar. These are all equivalent in this context. In this context, that means if you take any type of velocity, dimensional formula is same. That is in simple words. It may be a instantaneous velocity, or average velocity, or initial velocity, or final velocity, or change in velocity, or it may be a scalar as a speed. Like in all these things, the dimensional formula is same. So, since all these quantities can be expressed as distance by time, that is length by time, therefore, for all of them, the dimensions are L upon T, therefore, LT to the power of minus 1. That means L to the power of 1, T to the power of minus 1. L has a dimension 1, T has a dimension minus 1. Now, the expression which shows how and which of the base quantities represent the dimensions of a physical quantity is called dimensional formula of the given physical quantity. That means, in simple words, whatever you represent, that is M, L, T, M to the power of X, L to the power of Y, T to the power of Z, that is called as dimensional formula when you keep it in a square bracket. So, for example, already we have seen for the volume, it is M0, M to the power of 0, L to the power of 3, T to the power of 0. This is the dimensional formula. Keeping three of them together in square brackets, that is called as dimensional formula. It's nothing but dimensional formula means it's not a big thing, simple thing, very simple thing. Keeping M, L, T together in one single uh, pair of square brackets, that is called as a dimensional formula. So the expression which shows, this is the expression for volume M0, L3, T0. So the expression which shows how and which of the base quantities represent the dimensions of a physical quantity, in this case it is volume, it is called dimensional formula of the given physical quantity. In this case it is volume. So therefore for volume the dimensional formula is m0 l3 t0, and for speed or for velocity it is, sorry, sorry, by mistake, the cursor has gone front. Please excuse me. Now, we are talking about the speed or velocity, that is m0 l1 t minus 1. This is the dimensional formula. This is the dimensional formula for speed or velocity. Similarly, m0 l1 t minus 2 is the dimensional formula for acceleration, and m1 L to the power of minus 3 T0. This is the dimensional formula for mass density. You all know density is equal to mass by volume. Mass means m divided by volume. Volume is L to the power of 3. Therefore, m divided by L to the power of 3, that is m to the power of 1, L to the power of, this is this one, m to the power of 1, L to the power of minus 3. T has no dimensions, therefore t to the power of 0. This is the dimensional formula for mass density. An equation which is equating the physical quantity with its dimensional formula, it is called the dimensional equation. So if you take physical quantity, any physical quantity, write it in the left hand side, and right side RHS, you write the dimensional formula and combine them with the is equal to symbol, then it is called as dimensional equation. It is called as dimensional equation. It is nothing but write the physical quantity in the left hand side and write the dimensional formula in the right hand side. Equate both of them with the is equal to symbol. Then that is called as dimensional equation. See, for example, here I wrote volume V, that is LHS, and it is dimensional formula M0 L3 T0. Both are equated with is equal to symbol, and this is called as dimensional equation for volume. Similarly, speed, that is represented by a letter V, that is equal to m0 L1 t to the power of minus 1. Both are equated with is equal symbol. This is the dimensional equation for speed. Similarly, for force, that is F we have written in the left hand side, and its dimensional formula we have written in the right hand side, m1 l1 t minus 2, that is both of them are equated with is equal symbol. So this is the dimensional equation for force. Similarly, just now we talked about mass density, rho, this is a Greek letter rho, is equal to dimensional formula m1 l minus 3 t0. This we have written in the right hand side, equated both of them with is equal symbol. This is the dimensional equation for mass density. Thus, the dimensional equations are the equations which represent the dimensions of a physical quantity in terms of the base quantities. So, what is the dimensional equation? Dimensional equations are the equations which represent the dimensions of a physical quantity in terms of the base quantities. Base quantities means L, M, T, etc. So, as I have already explained these examples, I have given 4 examples here. And then with this, we can conclude our topic, dimensional formulae and dimensional equation. Dimensional formula is nothing but writing M, L, T with their respective powers in the square bracket. That is dimensional formula, and equating dimensional formula with the physical quantity, that is called as dimensional equation. Very simple. Once again I repeat, write the dimensions, that is m to the power of x, l to the power of y, t to the power of z, and keep it in a square bracket, that is called as dimensional formula. When you equate the dimensional formula with the physical quantity, like writing the physical quantity in the LHS and writing the dimensional formula in the RHS, then we can call it as dimensional equation. Thank you for watching this video. In the next video, we will discuss about applications of dimensional formulae. That is very, very important, which will be useful for the long answer questions. That is, three applications are there, and they will give any question on that to solve a particular problem. So, three applications of dimensional formula we will discuss in the coming video. Until then, bye. Thank you for watching this video. God bless you all.